Okay, hello to everyone. My name is Malinin Alexander. I will make a short presentation of modern trends in SpaceTech. I'll speak English. Probably it's not the best way for me to represent. So, but my friends asked me to make it in English. So if you have questions, I can repeat in Russian. Yeah. Okay, let's start. I have a question. What do you think when we're talking about the space exploration? Probably the first flight of Yuri Gagarin into space, or landing of the astronauts to the moon surface. Probably it's a flight of Voyagers out of the solar system, or maybe it's cosmonauts on the ISS. Each people consider the space exploration for themselves as different, but I believe that almost all of us are interested in space and interested what happened where and what is waiting us in upcoming maybe 20 to 30 years, and I would like to discuss it with you now. I would like to start from the boring digits. It's a research of Morgan Stanley about the space market volume, and now it counts of about 500 billions US dollars, and up to 31st year is going to be 600, and it's gonna reach $1 trillion by 2040. It means that the market is growing, and more and more money goes into space industry. It's getting more interesting for venture and institutional investors. And let's have a look the trend on venture investments in upstream space. Upstream, it means what all the stuff that goes up into space. It's a rocket, vehicles, it's satellites, hardware, space stations, whatever what goes into space. And you can see that the trend, what it grows year by year, excluding 2022, because the crisis starts and venture guys are a little bit scared of happening and stopped investing in risky activities. But I believe the trend will continue, and the growth of venture investments in space continue to grow year by year, and it reached $15 billion by 2021, and the lion part of this money goes to the few companies. Most of them goes into OneWeb and SpaceX. I believe you know these companies, and I would like to start from the first trend of it. It's low Earth orbit communication constellations. I believe what everyone knows, OneWeb's and Starlink constellation of SpaceX, but there are plenty of different of them, like Leasat, Viasat, Amazon constellations, and etc., etc. Many companies in many countries trying to make their own constellation, and we compete now. In fact, Elon Musk plans to launch 42,000 satellite of Starlink constellation, and by now it was launched 4,000 satellites. It's a huge amount of them. And OneWeb launched 550 satellites, and it's gonna bigger year by year. Here represented the Starlink satellites stacked under the fairing of SpaceX launch vehicle, and you can see we are trying to fit as much satellites as possible to launch them simultaneously. It's about 60 to 80 satellites in a row. And here is a fun picture how Starlink satellites was separated from Falcon 9, and each dot is a separate satellite, and astronomers are really unhappy with that. They argued with Elon Musk that what you are doing, you don't let us make our work because it breaks our research in deeper space. And finally, Elon decided to paint the satellite in black, so not to reflect the sun to the Earth's surface. What is the difference of LEO constellations, and why all the countries, all the big companies goes into this market? It competes with the traditional geo satellites, which flies at the height of 36,000 kilometers above the Earth, and they operate at equatorial orbit. The main thing of this orbit is thus satellite speeds with the same angular satellite flies with the same angular speed as Earth. So from the people at the Earth's surface, it looks like satellites stay at the same position. So it's very comfortable to provide the communication services like television, internet, everything joined this communication. But there are some limitations that cover LEO satellites, and first limitation is coverage. Geostationary satellites operate in equatorial orbit, and it works very poor in polar regions. For example, polar regions of Russia or Canada can be covered by a geostationary satellite. And LEO satellites are distributed, the constellation are distributed around the world, and it covers any point of the Earth, especially depending on the size of the constellation. For example, Elon Musk constellation now covers almost all the Earth. There's some spares because it's still not full, but the existence of the communication is high now. And this is very good, so you can have internet access from any point on the planet, and the speed is pretty high. It varies depending on the service between 20 and 2020 megabits per second. So it means you can watch high definition television, play games or whatever. Another feature of LEO constellations is latency. The problem for GEO is the height of the orbit, and signal goes up and down back for several seconds. It means some services are not achievable for you using geostationary satellites, for example, online games or, I don't know, maybe stock exchange trading, and the services where you need the speed of the signal. And LEO satellites solve this issue. We are flying at the orbits of the height between 500 and 2000 kilometers. It's much lower, cover of magnitude lower, and order of magnitude lower, and the speed of the signal is much faster. It is similar for the fiber optic connection at the Earth, so this problem doesn't exist. Finally, it means that you can work from any point of the planet. You can enjoy entertainment, multimedia, whatever, and there are no gaps at the planet where it doesn't work. There is some limitation. At the same time is a ground terminal of Starlink satellite. It's a dish with the software, and its price still pretty high. The price of the terminal itself costs between 2050 and I think $900, and the monthly salary is about $90 to $2050 as well, depending on the speed you can receive. And it's still pretty expensive for the most countries of the world, and the opportunity to make this service more affordable, it's getting the price of the terminal down and the monthly salary as well. However, at the same time, Elon Musk subscribers for Starlink service is already 1.5 million subscribers, and it grows year by year, so now it's on the growth. We'll see what happens, but this is still a limitation. The next trend I would like to say is direct communication between cell phone and satellite. For me, personally, it's a very interesting trend. At this moment, one company in the United States called AST SpaceMobile launched the satellite with a big antenna, big deployable antenna, and they tried to appoint the communication in 4G, not 5G but 4G. So it means it's existent smartphones what we have now, and they trying to appoint the communication in several countries, United States, UK, and some others, and they achieve the speed of data transmitting up to 10 megabits per second. It means that we can send data, we can voice messages, some information. It's not very high speed, but still you have a communication, and it's really a point. And another technology what now grows is a 5G communication, and many companies who make the chips for a smartphone, like a Snapdragon, Qualcomm, others, Nokia, not Nokia, we develop chips what already has included the opportunity to make the satellite communication. And companies who provide the telephony services like T-Mobile, Vodafone, etc. we already partnering with satellite manufacturers, satellite operators who will operate such constellations to provide the direct link between the satellite and smartphone with 5G chip inside. For example, SpaceX already partnered with T-Mobile. We are going to install at Starlink satellites such kind of chip for the next generation of the satellites and provide the direct communication with the smartphones. With this speed, it means that you can go anywhere. You don't even need a dish like this for traditional Starlink service. You just need your smartphone and you have the direct communication from all over the world, and I believe it's going to work in several years now. The main issue here probably is the frequency coordination, because frequency for GSM, for example, we are limited only for the ground usage but not for space, and ST Space Mobile just testing it in some regions where we receive the access, but it's still not possible to use it all over the world. If this issue gonna be solved for 5G frequencies, it means this it's usually international coordination, so finally it can be used from any point on the planet, and that's cool. We talk about the big constellations. Musk plans to launch 42,000 satellites, OneWeb, others, direct-to-cell communication. It's thousands of satellites, maybe 50,000 or even more. And it produces a lot of space garbage. And this is a big issue now. It's starting big issue. It started discussed maybe 10 years ago, but now it's really problem for the humanity. For example, there are 10 million objects in space less than 1 centimeter. It can lead to Kessler syndrome. Kessler syndrome is when several satellites hit each other, and there appears the cloud of particles. This cloud pass around the globe, hit other satellites, and there are more and more particles of space garbage, and finally all the Earth orbit would be covered with such particles, and we can launch anything into space. We would be imprisoned on the Earth for tens years, maybe 20 to 50. These particles can fly around the Earth for many years while we burn in the atmosphere, and we can't launch. It can lead what we can't launch the satellites, the rockets, and all the stuff what now operational in orbit would be destroyed as well. So we can't use communication satellites, we can use navigation, we can use images of the Earth. We would be blind and blocked at the Earth for many years. Another problem is the usage of the anti-satellite weapon in space, like did the United States, Russia, and China. We exploded outdated old satellites, and another thousands particles appear in orbit. People trying to solve this issue. Now appears many ideas and many startups on how to clean the orbit. The problem that small particles were flying at the speed of up to 10 kilometers per second, and it's equivalent, one particle of 10 centimeter size traveling at the speed of 10 kilometers per second is equivalent to the same 7 kilos of trotyl, of TNT. And it's huge energy, and it can't be just hidden. So the only option for us is to catch some big objects in space, like dead satellites or parts of the launch vehicles. And here is one of the examples how such garbage can be caught. Is a space mesh what deployed from the satellite, and finally both of them are decreasing their orbit and burn in the atmosphere. Here is another example when the satellite cleaner grab the outdated dead satellite and again trying to remove it from orbit. But at the same time, such satellites can be used for different purposes. For example, they can refuel old satellites and prolong their life in orbit. Good example of that is geostationary satellites. They usually operate for 15 to 20 years, and the point of stop working for them is the absence of fuel in the tank of the satellite. And it could be refueled, and his lifetime can be prolonged for 5, 10 or 15 years. It can save the satellite operator up to $200,000 and it is much cheaper than launch another big satellites of 3 to 5 tons in a weight. Meanwhile, there goes negotiations between different nations on how to solve the issue with the space garbage, and I see that the only option for us now is to make some regulation of that, and I believe that in upcoming future there appears a requirement for the operators of the satellite that their satellite should be deorbited in some special period of time, maybe in 5 years or after lifetime of the satellite, in maybe 2 years after lifetime, something like that. And in other case, we would be punished by some taxes. And it could be different hardware on the satellite. It could be some kind of sails, what open after the satellite was died and decrease the orbit and burn it out in the atmosphere, or some tethers with a magnetic field, what behaves the same. So many different options to do it. The next trend is space tourism. We all followed the launch of Virgin Galactic and Blue Origin companies when we launched their satellites into suborbital flight. Both flight was successful. Astronauts, people was delivered into space. Blue Origin a little bit higher. There are a Kármán line, which considered like a border between the atmosphere and space. The height of the Kármán line is 100 kilometers, and Blue Origin flight a little bit higher, something about 106 kilometers. Virgin Galactic couldn't achieve this point. The height was something like 95 kilometers. But meanwhile, it was cool, and it's a new trend, but the price for such a launch is still high. The upcoming launch of Virgin Galactica costs about $450,000 per person, and it's affordable only for billionaires still. We saw the launch of Crew Dragon, SpaceX's vehicle to International Space Station. Here is a docking of Crew Dragon to the space station, and another company, Boeing, developing their Starliner to deliver astronauts to the space station as well. And now a lot of private companies who are trying to compete for creating the new space station, private space station. You know that International Space Station works until probably 2030, and after that we're not planning to prolong its lifetime, and new projects will come, and the private companies trying to compete for that market. This is a render of Axiom Space company who plan to create their own space station, and there are some different of them, like Northrop Grumman company trying to make their own. Another one is Orbital Reef, Starlab. So several companies trying to compete at this market. Does it mean that we get opportunity to fly to the private space station upcoming future? I don't think really, because all of them are US companies, and we are trying to compete for NASA budget, because NASA opened the program for financing of private space stations, and they still need NASA financing, and I believe that the price would be pretty high for usual people. Probably Starship of Elon Musk will change something, dropping down the price to launch the stuff into space, but it is still very expensive. Another trend I personally like, it's colonization of the moon and moon bases. The only thing that why do we need it? People landed to the moon more than 50 years ago, and why we decided to come back there now? The reason that the moon is a source of resources for our planet. There are a lot of gold, platinum, and occasionally water. Water was found at the poles of the moon. It is hidden into craters and create in ice condition. Why do we need water on the moon? It's a universal thing. It could be used like a fuel itself, or break it down into hydrogen and oxygen. It can be used for lunar settlers, for drinking, for planting some greens. And finally, it could be used for protect people from radiation to gather this lunar regolith. And one important thing about the moon, it's very good for a post to move further into deeper space. There is no atmosphere, the gravitation is much lower than Earth one, and it's much easier to launch something from the lunar surface further in a deeper space to make the exploration. Another option to get the resources is mining from the asteroids. There are a lot of them between orbits of Mars and Jupiter in asteroid belt, and here is represented the drawing of Psyche asteroid. Scientists think that it consists of iron and nickel, almost full, and its price, just estimation of the price, about 18 quintillions. No, one quintillion US dollars. It's a digit with 18 zeros. In comparison, our total global GDP, it's about 100 trillions dollars. So it means what the first company who bring the asteroid to the Earth and can mine it can be the richest people in the world. However, I believe nobody plans to bring the asteroid to the Earth, but it could be placed in Lagrange point, L1. It's a point between Earth and the Sun, and the equivalence of a gravity allow the thing placed there to stay stable and not fly away from this point. It could be bring it there, and we can mine it and bring the resources back to Earth, or build something in orbit just close to this asteroid. And finally, I would like to say about the project I'm leading. It's called Guiding Star. It's a free CubeSat, small satellite with a laser on board. And the idea to point this laser, it's very strong laser, into the direction of the Earth and turn it on. And from the Earth's surface, it can be seen like a star in the sky. It can be seen by a naked eye from any point on the Earth. And we're trying to use this technology to make the service of transferring messages between the people. So you can pick the place where you want the laser was start brightening. You can pick the path when the satellite goes above this place, because we know the ballistic of the satellite further for the several days. So you may pick the most affordable path over that point. Create some kind of card. It could be picture, voice message, text, whatever, URL, emojis, and just pay it and receive the link. You can send this link to the addressee, and finally this person should go to the place. Their laser will turn on, and he can see it in appointed time. The light will start in the sky. It can flickering if you want. and finally you receive the message, your address will receive the message we sent. So its service was created for B2C customers and probably for B2B. It could be integrated into some application of the B2B client. It could be used like a gamification point or service for the customers of our client, or kind of viral marketing source. And another thing what we can do after launch of the first satellite is to create a brand logo in space. We can launch the swarm of such satellites with lasers and thrusters on board and adjust it on orbit that way that from the Earth it would be seen like a brand logo constellation. This brand logo can pass all over the world and can be seen by billions of people, and it could be a service, marketing service for big rich companies around the globe that would like to make the brand awareness or attract new customers. How it looks from the orbit, something like that. It's very, very specific thing to adjust the satellite. It's very complex thing to control it all around the globe. But it could be made with special algorithms. That's all. Thank you. Would be happy to answer your questions if you have some. Okay, I'm here.